Let's do a problem from your lab assignment. This is from section 7.8, problem number 4. Determine whether the integral is convergent or divergent, and if it converges, then evaluate it. We have the integral from minus infinity to infinity of 32 times, we got x squared divided by 9 plus x to the 6 dx. So this is an improper integral, and this is the kind where we have unbounded on both sides of the limits, so we're going to need to split this up in half. Half of it, well, not necessarily half, but split it somewhere in the middle, and 0 seems to be a nice number to deal with, so we're going to split it at 0. So this is going to go from minus infinity to 0, and then 0 to positive infinity. So we're going to have two integrals that we're looking at. Although they are suggesting here, since this is an even function where we put negative x in, and then we're going to get the exact same function, then this is symmetric about the y-axis. So this limit, or those two integrals, are going to be equal. That's this first integral and then the second integral are going to be equal. So we'll just say 2 times one of the integrals. So that's going to make things a little bit easier for us. We'll take the limit as b goes off to infinity of the integral from 0 to b of that integrand. And then now we're going to evaluate this integral. So we're going to notice that x to the 6th is actually x to the 3rd squared. And we're noticing that because the derivative of x to the 3rd is x squared. That will conveniently go away here with some constants around. And so we can do a u substitution. So if we let u equal x to the 3rd, du is going to be 3x squared. And x squared dx here, x squared dx can get replaced with a du divided by 3. So we will get a 1/3 out, and then it looks like they took this 32 out. So let's get the 32 divided by 3 out of the integral. And then our dx, x squared dx is going to be du, or 1 times du. And then our denominator would just then become 9 plus u squared. So now that we have that, we can do another substitution just to make this be 1 plus w squared. With a u equals 3w, then du is going to be 3 times dw. And that will allow us to replace our du with this 3. And so the 3 in here in the numerator and the 3 in the denominator would cancel, and that would just give us a 32. Actually, we also need to factor out a 9 here in the denominator. So after the 3's cancel, we factor out a 9. So it looks like we're going to get 32 over 9 as a constant out in front. So now that we have that, we remember that the antiderivative of 1 divided by 1 plus w squared is going to be the arctan of w. So don't forget your constants that are sticking out there. And then we get the arctan of w. Okay, so re-expressing the values in terms of x, let's backtrack. What does w equal to? W is equal to u over 3. And what does u equal to? U equals to x to the 3rd. So expressing this back, we get x to the 3rd power here, divided by 3. So now we put values of b in there. We're going to get, if you put b in there, you're going to get b cubed over 3 minus, now I don't see a parentheses around the arctan, which is what I would have done. So we have to make sure that we include the 32 over 9 as the coefficient there. And then we have the arctan of 0. I guess we didn't need that because the arctan of 0 is just equal to 0. So we'll put 0 here. And then now it's just a matter of finding out what happens to the limit as b goes off to infinity. So the integral, if you remember, was twice the integral from 0 to infinity. And so we have 2 out here. And then we got that to be equal to this expression, 32 over 9, the arctan of b cubed over 3. Now the 2 times 32 over 9 is going to be 64 over 9, so that's taken care of. And so we just need to figure out what the arctan of b is as b approaches infinity. Well, if you remember what the arctan looks like, the arctan function, as you get larger and larger, you're going to get it settles down to this graph to the value of 1.54, 1.58, 548, something like that. If you didn't know what that was, let's see if we could zoom in a little bit. It looks like this probably has to do with some trig function, right? Y is equal to pi is all the way up here. Let's take a look at y is pi over 2. And then if we take a look at the arctan, as we go off to larger and larger values, it looks like it's approaching that value of pi over 2. And we can think about that also as the tangent of pi over 2 goes off to infinity, and that's kind of like what's telling us in the graph. So we essentially approach pi over 2. Okay, so we'll go ahead and put pi over 2 here as our limit, and then we just multiply this. So 64, half of 64 is 32, so that's 32 pi over 9 should be a pretty good answer for this. Okay, so we actually found a value. That's important. So that means the integral is actually convergent. And then the value that we found is this. So that's 32 pi over 9. Okay, I hope that helps.